Assalamualaikum warahmatullahi wabarakatuh. My name is Mohd Safwan Arif bin Muhammad Sanusi, and my matrix number is B0918100532. And today I'm going to present to my panels about my PSM, which is the title is effect of laser engraving parameters on surface morphology and quality of stainless steel. And my supervisor is Professor Madya IR Dr. Muhammad Azli bin Abu Bakar. And we're going to the introduction part. So, the introduction. So, what is laser engraving meaning? Engraving meaning is a process of removing the surface of the subsurface by using friction or heat layer by layer to form the pattern. And laser engraving meaning is a process of creating pattern by transferring heat by using laser beam on the surface. We move to another part. So, as we can see, here is the important timeline of laser engraving, which is in 3100 BC in ancient Egypt, there was a founding of carving on the walls, which is doing by manually, by hand or hand tools. And in 15th century, Germany goldsmith engraved manually on the steel angle as their product. And 1960, Theodor Maiman discovered the first laser in the world, and 1980 Will Dahlgren, the laser engraving machine invented, which is first automated laser engraving machine. The figure beside me shows the laser engraving application. What it is? It can be used for the business, for marking application, and for arts making. Next is we're going to talk about the suitable surface to do the laser engraving. Typically, the laser engraving will found on the metals, but it is not limited only for the metals. It can be engraved the woods, the glass, the ceramics, maybe the stone, and some other suitable surface. So next, we're going to move on about the objective of my PSM. For this project, there are three main objectives, which is the first one is to laser engrave the surface of stainless steel using MOPA laser. Second is to identify the effect of the laser parameters on the surface of the stainless steel. And the last one is to study the structure of the stainless steel by using the microscope to observe the microstructure of the stainless steel after the engraving process was done. So, for this project, there are four main scopes that has been used to run the experiment and the project. So, the first one is focus on using laser engraving to engrave the surface of the stainless steel. So there is no other materials has been used in this experiment. Second one is using a laser engraving machine to make the pattern on stainless steel. Third one is the laser type that will be used only the MOPA fiber laser only. And the fourth is the maximum input power that will be used not be exceeded by 80% of power. So next, we're going to talk about the methodology. Here I show you the full methodology, which is the full flowchart from PSM1 until PSM2. So for the PSM1, it started with the problem statement, objective, laser engraving research, and finding suitable parameters for the PSM2. And for PSM2, where is the experiment has begun, and we run some tests on the engraved surface. We're doing some data analysis, and the result will summarize and conclude, and the project is end. So next, we're going to talk about the material that has been used in this project. The material that has been used is the Austenitic stainless steel, as shown at my side. The reason why it is chosen as the specimen, first is it have the excellent corrosion resistant. Second is ductile and readily formable. And third is excellent weldability. And the last one, it is hygienic with excellent cleanability, which is it is not rusty, and the surface is shiny. There are four main equipments that has been used. It is Adobe Illustrator, laser engraving machine, surface roughness test machine, and microscope. So for the Adobe Illustrator, Here we're going to design the pattern using the Adobe Illustrator. Second, the laser engraving machine, which is the process. The mobile laser engraving machine used to do the pattern on the material, surface of the material. As surface roughness test, it is to analyze the surface roughness of the engraved material. And the last one is microscope. It is to do the observation of the microscopic view for the microstructure of the engraved surface material. Here is the video of the engraving process. The engraving process were done by using the engraving machine, and the pattern that has been designed in the Adobe Illustrator will transfer on the stainless steel, which is the surface of stainless steel, and the surface is being engraved by the engraving machine. Next for the process is the surface roughness test, which after the surface of the stainless steel has been engraved, the surface roughness test were done to get the data of the surface roughness, which is in micrometer. The surface roughness test data will vary because for each square the surface roughness is different. So for the last process of data collection is the microscopic observation. The microscopic observation is to observe the microstructure of the surface of the stainless steel for each square, which is different parameters that has been engraved on the surface, to see is it corresponding to the surface roughness value, and to find the reason why it is too high or too low in value of the surface roughness. As you can see here, this is the result for the experiment 1, which is the parameter used is the laser frequency versus the laser engraving speed. So the result, the square has been divided by the column, which is the column use the alphabet A, B, C, D, and the row has been chosen by number 1, 2, 3, 4, 5. So as we can see here, the colors appears in certain parameter that has been used. So we move to another result of the experiment 2. So for the result of the experiment 2, the method of the tagging has been used is same with the previous square, which is the column A, B, C, D, and the row is 1, 2, 3, 4, 5. And for the normal vision observation, we can see here that when the power is step up, so the color of the engraved surface become darker, but they also appear in D1, the color show up. So we're going to analyze it by the surface roughness value. So here is the surface roughness data for the experiment 1. The surface roughness test has been done for each square 3 times to get the average, and the average has been tabulated as shown in the table 1. At the blue side, it is the speed parameter that has been used, and the pink side, it is the frequency parameter that has been used for the experiment 1, and the white section is the value of the surface roughness data that has been averaged. And from the table 1, I make another table to compare the minimum roughness and maximum roughness value to see what is the parameter corresponding to the value of the surface roughness data. So I can conclude that at the speed of 3000 for the experiment 1, it will give the result of the smooth or low surface roughness data. And for the maximum roughness data, the speed is 800 mm per second. So the higher the speed, the smoother the surface, or I can say that the higher the speed, the lower the surface roughness value. So here is the graph of the surface roughness versus speed for the experiment 1. The data of the graph is taken from the table 1. As we can see here, we can conclude that at 800 millimeter per second of speed, the value of surface roughness is high, and at 3000 millimeter per second of speed, the value of surface roughness is low, which is, we can see here the pattern is decreasing when the speed is increasing. So here is the surface microscopic vision for the experiment 1. So I've chosen the D column to show the microscopic vision for this presentation. So the frequency used for D column is 80 kHz, and for the minimum roughness value, the speed is 3000 millimeter per second, which is give the value of the surface roughness is 0.1 micrometer. And for the maximum roughness, D column, we got the speed is 800 millimeter per second, which is contribute the value of the surface roughness is 0.283 micrometer. So the yellow box indicate the minimum roughness for the D column, and the red box indicate the maximum roughness of D column. So in normal vision, we can see that in the red box, which is the maximum roughness of D column, we can see the surface appears with the violet color on the engraved surface, and the yellow box, which is the minimum roughness value, for D column, we can see that the shiny surface appears on the surface. So if we zoom in for the minimum roughness, we can see that there are more dots produced on the surface, which is the dots is the burn marks happened by the engraving surface, engraving process. And if we zoom in into 20x of scope, we can see that the surface is smooth. So for the maximum roughness, we can see that 5x in 5x scope, the violet color is still obvious, and in 20x scope, we can see that the surface is irregular, which is there are cracks and dots, which is contribute to the high value of the surface roughness, which is 0.283 micrometer. The irregular of the surface is happened by the melting process that has been done in the engraving process. So here is the surface roughness data for the experiment 2, which is the laser frequency versus laser power. For each square, I've taken 3 times the surface roughness test for each square. So to do the average, and the average is tabulated as shown in table 1. So the blue side is the power parameters, and the pink side is the frequency parameters. So the white section is the surface roughness data that has been averaged in micrometer. So I've done another table, which is in table 2, to compare within the minimum and maximum roughness for each square, for each column. So I can conclude that at the power of 30%, it contribute the low value for the surface roughness for the experiment 2. And for the maximum roughness, I can conclude that at 80% of power majority, it will give the high value of the surface roughness in micrometer, except there is only one data is difference, which is at 60% when the frequency is 40 kHz, which is give the result of the surface roughness data is 4.290. So here is the graph of the experiment 2, which is the laser frequency versus laser power. So the graph data is from the table 1. So we can see here the pattern is when the power is 30%, it shows it will give the minimum roughness data, and when at the end of the point, which is at the 80%, we can see that majority of it will give the value of the surface roughness data is high. So I can conclude that when the power is rising or increasing, it will contributing in high surface roughness value. So here is the surface microscopic vision for the experiment 2, which is laser frequency versus laser power. So again, I've taken the D column to make the comparison and analysis. So for the D column, the frequency that has been used is 80 kHz, and for the minimum roughness, it appears that at power of 80%, at power of 30%, it will give the value of surface roughness is 0.269 micrometer, and again it appears that at the power of 80%, it will give the maximum roughness value of the surface roughness data for the D column. It is 0.871 micrometer. For the normal version, we can see that in the yellow box, which is indicate the minimum roughness for D column, it appears that the surface appears with the bluish color on the surface after the engraving process were done, and the red box indicate the maximum roughness, which is we can see that the color become darker and darker. It is due to the burn marks happen by the engraving process. So if we zoom in using the 5x microscope for the minimum roughness of D column, we can see that the surface appears with the dots, which is the burn marks, compared to the maximum roughness of the D column for 5x. We can see that the burn marks is so obvious, and the surface is shown is so irregular. So for the 20x of the D column for the minimum roughness, we can see that the surface is so smooth compared to the 20x of the maximum roughness of the D column, which is the surface is so irregular, and we can see that there are the surface deformation due to the melting after the engraving process was done. So the melting and the irregular surface will contribute and conclude that why is the value of the when the power of 80% in D column give the high value of the surface roughness. So for the conclusion, the main objective, which is to laser engrave the surface of the stainless steel using Mohd laser. Second objective, it is to identify the effect of the laser parameters on the surface of the stainless steel. And the last one, the last objective is to study the structure of the stainless steel by using the microscope to observe the microstructure of the stainless steel after the engraving process was done is achieved. And I can conclude that for the experiment one, when the speed is higher, the value of the surface roughness is getting decreasing, which is the speed. When the speed is slow, it will give time to melt the surface of the squares, and if the speed is high, the burning time or the lasering time is short, so the melting process is barely done on the surface. And next is for the experiment 2, I can conclude that the higher the power, the value of the surface roughness data will become higher. It is due to when the power is high, the tendency to melt the surface is high. That's all from me for PSM project for my PSM. I am Mohd Safwan Arif bin Mohd Sanusi, and my matrix number is B0918105332. And thank you.